Examples for section 9.3 in problem stats. And this problem says a researcher collects the data shown and concludes that there is a significant relationship between the amount of radio advertising time in minutes per week and the weekly sales of the product in hundreds of dollars. So this first column is our time that we're advertising on the radio in minutes per week, and this second column is how much money we make from the product in hundreds of dollars. So like this 26 would be $2,600 that we make in 1 week. The 38 would be $3,800 that we make off of that certain product. And we want to, we're going to use a table and calculate the sum of the difference of each observed Y and the corresponding predicted Y. That's our unexplained variation. Identify the number of ordered pairs in the data set, calculate SE, and then interpret the results. And we're going to do this two different ways. I'm going to do it using the one chart, then do it using the other chart, or the other formula, I mean. One formula, then the other formula, two different charts. And we're also going to make an interval. We're going to pick a X value and make an interval what we think our Y is going to be, all for the same data. So we're using these two formulas. First, I'm going to use this formula. And then the second example, I'll do the same information and stuff using this formula, and they each have a different chart. The first chart, that's this chart. I know you can't see this last one out here. Remember these last two out here? These last two we really don't need, but I'm probably going to use them and find them anyway. Again, if you take these and you stick these numbers into your list on your calculator, you can find the sum of all the X's and the sum of all the Y's just by using the one vars. So we use, if we're going to do this, we just deal with the X's as one thing, the Y's as a separate thing, using the one var stats under the stats, under your stat bar on your calculator. And when I did that, I came up with, when I found this sum was 280, and this sum was 452. And I also wrote down this, whether it'll help us here or not, I don't know, but I wrote down that X bar equals 35, and Y bar equaled 56.5. The calculator, if I punched it in and I use that number 1 on there, which just says 1 var stats, it'll tell you all that stuff. Just trying to make it a little easier to do this. On this one, this next column, this again is the hardest column to do. On this column, what you have to do is you have to take your equation, and I'm sorry I forgot to write down the equation. They told us, and we could have found the equation ourselves by finding A and B on our calculator. The equation is Y hat, probably not going to have room there. Let's write it down here. Y hat equals 1.405x plus 7.311. And again, if you have all of these, the X's and Y's in your calculator in the list, you could come up with this equation yourself. I didn't have to give it to you. You could find it yourself by doing on your calculator, again, just like we did before. You hit stat, calculate, go down to linear regression, hit enter, put in your two list 1, comma, list 2, and it's going to tell you what A is. Remember, this is A, the slope, and B is the y-intercept. So you can find that yourself. What we're going to do with each one of those, we're going to take the x, whatever x we have, and we're going to stick it into this equation, and that's going to tell us our predicted y value, our y hat. So for the first one, I'm going to stick in, I'm going to type this right into my calculator just the way that I have it here, and I'm going to do 1 or 2 of these, and then hopefully you'll get the idea. For x, I want 15 plus 7.311. If you just type that all right into your calculator, just like I have it right there, it will give you your y hat. So for the first one, when I typed it in my calculator, I ended up with 28.4, and I rounded it off. And the answer I got, and where I got this from, that their answer is a little, it's not exactly the same. Mine's a little off from theirs, just for the simple fact that I rounded a whole lot more than they did, because I want you to know how to do this stuff basically. I don't want you to, we're not being real precise right at the moment. Then next, I'm going to plug in the next x. So I've got 1.405, and our next x is 20. Ignore that. Plus 7.311. Type all that into your calculator, and when I typed it into my calculator, I came up with 35.4. And that's all you're going to do. Next 20, well, we're plugging in 20 again, so this is going to come out to be 35.4 again. No reason to plug it in a second time. Then the 30, we plug it in, same, this should have been 20 right there. We plug it in right there in that spot, plug it into our calculator, and I'm just going to write the rest of these in. Next one came out to be 49.5, next one came out to be 63.5, then 70.5, 77.6, and 91.6. And again, that's probably the hardest one, or the hardest part of all of this, is you got to take each of these x's and plug them in to figure out your predicted y using your regression line. Then this next column, you'll notice right here, we got y, we got our y hat, and all this column's doing is subtracting those two. So we just take this number minus that number in each one of these. Just subtract all the way down through here. On the first one, if I subtract 26 minus 28.4, I end up with negative 2.4. Next one, I end up with negative 3.4. Same thing on this, or no, I'm sorry, this is 38 minus that, so that's 2.6. And I punched all these into my calculator, so I'm just going to write in the rest of them. This one ends up being 6.5, then negative 9.5, and 7.5. All you're doing is subtracting this number minus that number, the y minus the y hat. Next one comes out to be, let's see, I lost my place here, 2.4, and then the last one is negative 3.6. So that's all of that column. Then the next one, you're just squaring each of those numbers. And remember, we really don't need these positives or negatives, because when we square our answer for this column, it should come out to be a positive. So when you're punching in your calculator, don't bother to punch in the negative. Just know that your answer is going to end up being positive and write down that answer. So on this next one, when I did this, I came up with 5.76 on this one. Squaring the next one, I got 11.56. Then 6.76. Then 42.25. You're just squaring. You're just taking each one of these answers and squaring it. That's all you're doing. Each one, squaring it. Next one, 90.25. That should be a 2.5 there. Then 56.25. Then 5.76. And then the last one is 12.96. And then the last thing that we really have to do, I'm going to do these other two columns also, but the last thing that we really have to do to find our SE is we've got to add all of those up. So you just punch all of these into your calculator, add them all up. That's our unexplained and that's not the last thing we have to do, but that's so that then we can use the formula. So we add all those up. When I added all mine up, I came up with 231.55. So that's all of these added up. Now before I do these last two columns, I'm going to go on, and I know I have 231.55. I'm going to go on and I'm going to go ahead and find our SE. Remember the formula that we're using for SE looks something like this. It's got n minus 2 on the bottom, and then on the top is the y sub I minus your y hats. And all of that is squared. Well, this whole thing right here is what we just found over there on the last slide in that column. So let's go back to that real quick. 231.55, that's the number that's on top in there. And then the other thing that we need is we need our n. Our n is 1, 2, 3, 4, 5, 6, 7, 8. So n is 8 in this case. So all I'm going to do is plug all that in. The top part was 231.55. The bottom was 8 minus 2. Ignore that. Well, 8 minus 2 is just 6. And you can grab your calculator and just hit second square root 231 divided by 6. Some of you will have to close your parentheses or put parentheses around it maybe to make sure you're getting the right answer. You might want to check yours with what I'm getting ready to tell you the answer to this is, just to make sure. And it came out to be 6.21. Now our explanation for that again is the standard error of the estimate. Again, that's going to stay the same every time if you're explaining this. The standard error of the estimate, and then we want what Y was, and Y this time was the weekly sales of a product. And then after that, we put for a specific, and if I could write for a specific, and this is where we put in our X, which X this time was add time. So add time specific, we probably should put specific amount of add time, just to make the sentence make sense. And then our last part is about, and we stick in our number. Now for this number, we got 6.21. Remember that all our stuff was, our sales were in hundreds of dollars, so what we have to do is bump this over 2 places. So that's actually $621. So the standard error of the estimate of weekly sales of a product for a specific amount of ad time is about $621. Now I'm going to go back, and I'm actually going to do these other 2 columns just real quickly. The only reason I'm doing them is because this last column is your explained variation. On the homework and stuff, you won't need any of this, but just so you can see it, it's not all that much more work. This is your explained variation here when we get this total, and then we could take these 2, add them together, and that gives us our total variation. Which for other things, not for what we're doing right now, but for other things you may need. So that's the only reason I'm doing these 2 columns. Remember that this, not sure what happened there, that this column, this last column right here, is just the next to last column squared. So it's just got all that in parentheses and it's squared. I know you can't see it because my recorder's in the way. But all we do here, for this column, we're taking y hat, which we just found right here. In this column, all the way down through here, we're taking these y hats, pen would work, and we're going to subtract off y bar, which we can find by using our calculators. Again, the 1 bar stats, we can find that. And I've done all that, so I took 28.4 minus 56.5, so on, all the way down through here, and I'm just going to write in the answers. This ended up being negative. Pen all of a sudden quit working. Negative 28.1. The next one came out to be negative 21.1. Next one was negative 7, or no, I'm sorry, that's wrong. Negative 21.1, again, they were the same. And then negative 7, and then a positive 7, then 14, then 21.1, again, and then the last one was 35.1. So all I did was I took this column and I subtracted off y bar from each one of them. And then this last column, all it does is it takes each one of these and it squares it. Here I got 789.61, 445.21. Remember, all your answers here should be positive. This one here again is 445.21. And this one's 49, 49. This one's 196. 21.1, we already did that, it's right up here, 445.21. And then the last one, 35.1 squared, ended up being 1232.01. Once I have all that, I'm just going to add up this whole column right here, find the sum of it, and I've done that already, and it was 3,651.25. That's our explained variation. And again, if we wanted to find R, we could take explained variation over total variation, and that should give us what R is, just another way to find R. Probably would never do that again because you can do it on your calculator. But we could do that, and if we wanted to find the total variation, we just take these two and we add them together. Again, those last two columns for your homework, you don't need those last two columns. But they're not really all that difficult to find. Next, I'm going to use this chart, and I'm going to use the other formula to do it. So I have this chart, and we're just going to go through here, and we're going to do each one of these. And you can do these either way. You can find your S sub E, the standard error, either way. It just depends on what you're doing, all right? Sometimes it's easier to use this chart. Sometimes it's easier to use the other chart, depending on what else you're going to do with it other than what we're doing with it. So on this, all I'm going to do, this column right here, find x times y, you just take 15 times 26. So you're just multiplying each one of these to get that next column. 15 times 26, I grab my calculator, I do it, it comes up to 390. Then 20 times 32 comes out to be 640. And then 20 times 38 comes out to be 760. And I've already punched all these into my calculator. So I'm just going to go ahead and write them down. The next one ends up being 1680 when you multiply those two. Then 2160 when you multiply those two. Then 3510 when you multiply those two. 4,000 when you multiply those. And then the last one ends up being 5,280. So that's just taking your x times your y and getting that column. The next column, x squared, you just take this, each one of these x's, and you square it. So you punch it into your calculator. 15 squared is 225. 20 squared is 400. 20 squared is 400 still. 30 squared is 900. 40 squared is 1600. 45 squared is 2025. 50 squared is 2500. And then the last one, 60 squared is 3600. And something I forgot to do on each of these columns is I should have added them. Again, if you punch these into your list, like list 1 and list 2 on your calculator, it'll add these for you. It'll add up all the x's. And when I punched it in my calculator, because I didn't want to add them up, I was being lazy. I figured if I'm going to punch in all those numbers, I might as well put them in the list. I came up with 280 for that one. I came up with 452 for this one. On this one, I forgot to add up the list down here. You just add all these up, punch them all into your calculator, add them all up. When I did that, I came up with 18,420. This list, I added them all up, and I got 11,650. Then the last column, you're just going to take each of these y's, and you're going to square them. First one, I got 676. Next one, I squared 32, and I got 1024. Then I got 1444. Then I got 3136. Then I got 2,916. Next one, 6,084. And 6,400. And then the last one was 7,744. Once I have all those, get your sum down here, you just add them all up. And when I add them all up, I got 29,424. Once I have all of those, then I can use the other formula if I wanted to use that other formula to find the standard error. So I'm going to go on to this next slide. And the other formula is this, SE, ignore that, equals square root sum of the y squared minus b times the sum of the y's minus m times the sum of x times y, all that over our, ignore that, our degrees of freedom, which is n minus 2. And a whole bunch of these. This y squared we have in our chart over there, this y total we have in our chart over there, the x times y we have in our chart that we just got done doing. The only things that we don't have are the b and the m. And again, to find b and m, you go on your calculator and you actually on this one, they gave us the equation. They told us, but you could go on your calculator and find it. They told us the equation of this for y hat equals, and I just have to find the equation again, 1.405x plus 7.311. Again, we could have used our calculator, and this is A, this is B. We could have put both of them in list and did second stats, go down to linear regression, put in list 1, comma list 2, and it would tell us what A and B are. So however you find it, that doesn't matter. All that matters is that we have everything that we need to stick into here. The sum of the y squareds was 29,424. Minus B is 7.311. Times the sum of the y's from our chart that we just got done doing. The sum of the y's was 452. Minus the slope is your A right here, that's 1.405 times the sum of x times y from our chart again was 18,240. Now what I would do if this is me, I punch all, and we can go ahead and write down the bottom if we want. N was 8, so this is 8 minus 2 on bottom. I punch all of this top into my calculator, just like it looks right there. Once you do all that, then in my calculator I hit divided by, and I can do 8 minus 2 in my head, that's 6. So then I just hit divided by 6, and I write down that number, because we still got to take the square root. And I came up with 39.888, something like that. Then you take the square root of that, and the square root of that number is going to equal about 6.31. So that's our standard error of the estimate. When we did it the other way, probably, I don't know if I rounded off more in one or the other, but when we did it the other way, the standard error came out to be 6.21. So it's a little different, but not a whole lot. Again, this means, because it was in hundreds of dollars, so this means $631. This meant $621. So two different ways to do it. I can't tell you which one's easier, which one you should use, because the book uses the first method that I did there, and they probably have a reason for using the first method. Just depends on what else we're going to do with it. If we were going back to the very start of this chapter, and we were still finding slope, the y-intercept and r, and I was making you do it out longhand, then it'd be better to do SE, the second method, because we already have that chart. All right, a prediction interval. To do the prediction interval, some things we already know, like we just found SE. So I'm going to write that up here. We're going to say it was 3.21. We used the first one that we came up with. We know that n is 8. Well, if n is 8, remember your degrees of freedom this time. It's not n minus 1 anymore. That's why I didn't like when some people were putting n minus 1 on the symbols and definitions, tests and quizzes. It's degrees of freedom, because now the degrees of freedom are n minus 2, which is going to be 6 this time. And they tell us that our C that we want is 99%, so our C is going to equal 0.99. We're going to use our chart. And instead of me trying to go back on the chart, you're just going to have to take my word for it, go back and find that other chart. We're just going to use this number, our degrees of freedom. If you have your chart out, you can follow along. Your degrees of freedom are 6. So we go down to 6. And our C is 99. That's our confidence level. So we go over to 99. And it looks like it's 3.707. So that's our TC right here. So our critical value, our TC, is 3.707. Our SE was 3.21. So we know these two things already. We know what n is. We're going to stick in 8 right there in place of n. We know what n is up here. That's 8. N here is 8. So we can put 8 in everywhere that we see n. These other 4 things, some of them we know, some of them we can find. Actually, the one that we know, this x sub 0, that's the x that we're predicting off of. And they tell us that we want to predict off of 35 minutes. So that's our x sub 0 is the 35. So right there we stick in 35. I'm going to rewrite this over on the side here in a second to make it look a little better. The other 3, if you go to your calculator and you use the 1 var stats and you have all the x's put into a list, it will give you these answers that you're going to put in there. So I have mine put in already. If I go to stat, calculate, the very first one is 1 var stats. And I'm going to put them in list 1. So I just put in list 1. All you're putting in is one of the lists now. You're not doing, because we're just dealing with the one variable, just the x's. And it tells me the x bar is 35. Probably shouldn't have picked 35 as what I wanted to predict on, but oh well, we'll try it and see. X bar is 35. x squared, the sum of all the x squareds, that's right here. It tells you that, and it's 11,650. We could have also got that from that other chart. And then this one we actually have to do a little work on, because the calculator will tell us what the sum of all the x's is. That's this on your screen there. And it's 280, which we already found, but we're going to have to square it. All right, so I just took a second and rewrote all of this. So this is our whole equation now for E, our margin of error. And all we're going to do now is do the math. When you do this math, no real easy way to tell you how to do it. As I'm going to do it, I'm probably going to do this top part first, then the bottom part, then divide that, and then I'll hit that answer plus 1 divided by 8 plus another 1, write down that, everything that's under the radical, then worry about taking the square root and timesing it. So if I go through and I do that, so if I take the top, and I know our top's going to be a little screwed up because I picked 35, which happened to be our X bar. So our top's actually going to be 0. So this whole thing, everything right here is going to be 0. So it's not going to come out like some of the other problems might. But again, I would punch in the top, 35 minus 35, square that, then hit times 8. That gives you the top part there. And then you can hit, you can try to just hit divided by and then put the bottom part in parentheses. You might be better off just to see what it is and write down both of them. So I got 0 on top here, and on the bottom, if I punch all that in just like it is, 8 times, and you could even put in parentheses and not put in the times, 11,650 minus 280 squared, and I get 14,800 on the bottom. Then I would divide those two, which in this case, when I divide them, it's going to come up to be 0. But now I have that answer on my calculator, and I would just hit plus. One divided by 8 plus 1, and I end up with everything under this radical, all of that came out to be just 1.125. And now I'm going to just take the square root of that. Square root of 1.125, it equals, and then all this stuff outside you're just going to multiply by these two things. So then I already have the square root answer in my calculator, so I'm just going to hit times 3.21 times 3.707, our critical value there, and I end up with E equals 12.62. Once you have your E, we also need to find our Y hat. To find our Y hat, we have to go back and use our equation again, which again, I lost my equation. It was Y hat equals (1.405x) plus 7.311. And all I'm going to do, we're trying to predict for x at 35, so right here in place of x, I'm gonna stick in 35, and on my calculator, I just punch all that in. 1.405 times 35 plus 7.311. And I end up with 56.486. I'm going to go 56.49. So our y hat, what we're predicted off of is 56.49. And we need these two things to write our interval. So 56.49 minus 12.62. Our y is in the middle here. And then 56.49 plus 12.62. Do the little bit of math here, and that's going to give you your interval, and then I'll explain it. So we've got 56.49 plus 12.62, that's 69.11. And then on the other side, 56.49 minus, or I did it wrong. I did it backwards. Ain't going it. This should be 69.11. And then on the other side, where we're minusing, 12.62, and that's 43.87. So that's our interval. And what we're saying is we're 99% confident that if somebody bought 35 minutes of ad time, that the amount that they make off of their product would be between, and again, remember this is in hundreds of dollars, would be between, if we bumped it over, 4,387 to 6,911, or 6,911. So just one more time. So we're saying that we're confident, 99% confident, that if they bought 35 minutes, that their product that week would make from $4,387 to $6,911. We're confident, 99% confident it would fall in that range. Hopefully that helps. Sorry this video is longer than I wanted it to be. Do your best on the assignment. I'll put it on Moodle and everything. And hopefully you'll have some, you can ask questions, whatever, and I'll try to send out here in a couple days the answers to the assignment so you can check your answers and stuff, see how you're doing.